Hello guys, welcome back to another video. My name is Dylan, and in this one, it's an exciting one. We're going through the entirety of paper 2 for maths from the 2025 year 6 SATs papers. Here it is. It's the first reasoning paper, so some tricky questions ahead. Let's dive straight in and see exactly how to answer them. So pass the instructions to question 1. Circle the angle closest in size to a right angle. So straight away, we need to know that a right angle is a perfect square, or we write it as 90 degrees. Now, you do get a protractor in this test. So if you are confident using a protractor, you could be testing all these angles and this bottom one here. You could, by eyesight, probably get rid of this one. That is way too big, too much of an obtuse angle. That's much further away from a 90-degree angle. And out of these 4, we get some closer ones. This one is quite acute, a bit too small, but then we kind of get closer here. Just use your protractor. Well, the one you should be circling is this one here. And again, even just by eyesight, we can see it's pretty close, despite my wonky line, to a 90-degree angle. But just make sure you get a protractor for a reason, so use it. Question 2, write the 2 missing numbers. This is an interesting way of portraying adding 1,000 going that way or adding 100 going down. If I want to get to the top left, I need to go backwards. So I'm not going to add 100 from 5,350. I'm actually going to take it away. So here I'm going to get 5,250, which fits the rule nicely. And then going to the right-hand side, I add 1,000. So I have 7,550. If I add 1,000, I get 8,550. Always in these types of questions, we get some kind of inverse going backwards. Just be aware of that. Question 3. This is Layla's money. This is Adam's money. How much more money does Layla have than Adam? Well, we just need to add this up. Simple as that. This is a £2 coin, and these are pence coins. So that's where we're going to try and trap people here. So Layla in total is £2, then the decimal place for 50 and 20, which is 70 pence. And here Adam has 50 and 50 and 50. So although these are pence, 50 plus 50 is 100 pence, which is a pound. And then we have 50 pence plus 20 plus 20. That gives me 40 plus 50, so £1.90. And if I want to know how much more money Layla has, I'm going to do £2.70, take away £1.90, and there is no harm whatsoever in just whacking it in column method like this, doing some exchanging, and getting 80 pence as the answer. You can write it either like this in pounds, 0.80 with the pound sign, or you could just write 80p, just like that. Next one. This is a coordinates question. We're given a grid and a quadrilateral has been drawn, A, B, C, and D. Let's take a look what the question says. Match each point to its coordinates, A, B, C, and D. So let's start with A. It's here. We go along and then up. Well, actually, we don't go along at all. So it's 0 for the first coordinate of the x-axis, and then we go up 3 to A. So I'm going to match up A with 0, 3. Now let's try B. Okay, cool. Starting at 0, 0, we go along 2. And then how far up do we go? 1, 2, 3, 4, 5, 6. So B is 2, 6. Going to match that up nicely. Notice how they have 6, 2 as an option. Trying to trick you into going up before you go across. We know we go across and then up. Let's take a look at C. It's the furthest out one. It's 8 across. And then we go 8 up. So C is 8, 8. Going to match that up there. And guess what? We don't need to waste any more time. If we've got these 3 and we're confident with them, well, D must be 6, 2. We can check it if we like, if we have time at the end. 6 across and then 2 up. Good. We're good to go. The trap there would be mixing up 6, 2 and 2, 6. But if you're confident with your coordinates, quite a simple question. Olivia counts in 8s starting at 0. This is just a fancy way of saying Olivia says her 8 times tables, because everything starting from 0, if I add on 8, is going to be my 8 times tables. Tick all the numbers Olivia should say. Again, just a different way of saying tick the numbers in the 8 times table. 24 is 3 times 8. 42 is not in the 8 times table, so we're going to leave that blank. 78 is not in the 8 times table, so I'm going to leave that blank because 80 is, so 78 wouldn't be there. And this is the first time we go past the 8 times table that we learn. We learn all the way up to 96. Let's just jump straight to that one. Add on 8, we'd get 104. Add on 8, we'd get 112. So this number would be said. Remember, just because we learn up until 12 times a number doesn't mean that's where the times table actually stops. So you do have to add on sometimes as well. Question 6, we have a number there, 5,639,728. Which digit, place value, is in the hundred thousands place? Well, 9 is in the thousands, So 3 is in the 10,000s. So the 100,000s is the 6. Read the question carefully. Which digit is in the 100,000s place? The digit is 6. Do not put 600,000. That would be incorrect. It's asking you for a digit. Be really careful. What is 2,000 more than 5,639,728? Well, I want 2,000 more, and notice it's 9 in the thousands column already. So you should be thinking straight away, if I add 2,000s, I get 11,000s, and I can't fit that into one place value column, so I know it's going to affect the 10,000s. So the best way to think about this now, instead of thinking about it as 9,000s, think about it as 39,000s, because 39 add 2 is 41, which just means when I write out this number, it's going to be 5,641,728. So it's always good to be thinking about that next place value column when you're adding things that bridge past it. So we've already got 9. If we add 2, it's going to be 11. It's going to affect the next column. Notice how in the second question, I had to write the whole number out. In the first question, I had to write a digit. Read the question really carefully and what it's asking for. Here is a graph for converting kilograms to pounds. So we have pounds across the bottom and kilograms up here on the y-axis. Use the graph to convert 5 kilograms to pounds. Okay, so for this conversion chart, we'd have to go to 5 kilograms, which is here, nicely along this line, and we'd managed to get right there, which is a nice overlap. So down here to 11. So the answer here is 11 pounds. And then this next one's really interesting because it's a rounding question, but we're using a graph, which actually makes it easier. Let me show you how. Use the graph to convert 7 pounds to the nearest kilogram. Okay, cool. So we go to 7 pounds, which is here, and we have to go up to our line, and we'll notice it's just there. What is that to the nearest kilogram? Well, look, on the left-hand side, we have the kilograms on each line. This line is 3 kilograms, and the line above it is 4 kilograms. What is this closest to? And it's very obviously closer to the bottom line, which is 3. So we put our answer as 3 kilograms. A very easy way of rounding when we see it visually like this. Literally, what is this point closer to? The 3 to round down or the 4 to round up? It's closer to 3 kilograms. So that's the answer to that one. Question 8. I thought this was a really interesting question because it's a reflection question, but we're so used to seeing grids when it comes to reflection. This is really doing some problem solving in your mind here to try and map that onto circles. Draw the reflection of the shaded shape about the mirror line. Use a ruler. You'll be using a ruler, but I'm going to show you my technique. The best thing when you're reflecting a shape like this, a polygon, is to get the corners and map them on. So this corner here that I'm drawing would map here to this part of the circle or the semicircle. This part up on the top left joins together with this, but it's going to be mapped up there. So straight away with a ruler, your line will be much straighter than mine. I'm going to match those up. And then I'm going to take the bottom one here. Notice how this corner is actually matching up here. It's not going all the way to the bottom. It's going to this part of the semicircle. And again, these lines match up. You will use a ruler to be much neater than I am. And the final corner is right here, mapped on to this equivalent space there. And then the last thing we do is just join up the last 2 corners, just like this. Mine looks wonky. You'll be using a straight line, but the important thing is that these 4 vertices, these 4 corners of this shape, all match up with exactly the right position over here. Use the grid to get the right place. Then you're golden because you can use the ruler to make sure your lines are much straighter than my lines. Question 9. Ali has 35 red counters. He divides them into groups of 3. What is the greatest number of groups of 3 he can make? Well, if you have 35, this is essentially asking you how many times does 3 fit into 35? So we're doing 35 divided by 3. How many times does that fit in? Well, it's not going to go exactly, but I can still do this with a remainder because I know that 3 multiplied by 11 is 33. So I can get 11 groups of 3. 11 groups of 3 is 33. And I'd have 2 counters left over. I can't make another group of 3, they're just remaining. But the question asked me, what's the greatest number of groups he can make? If you have 35 counters, you can make 11 groups of 3. Next question, Maria has 35 green counters. She divides them into groups of 4. How many counters does she have left over? Notice how this is flipping the question. So, again, count in fours. How close can you get to 35? If you count up in your fours, you can get to 28, then you can get to 32, but you can't get to 36. So you can have 32 of your counters in groups of 4. That would be 8 groups, exactly. But Maria has 35 green counters. So how many are left over? There are 3 left over, because 35 is 3 more than 32. And you can't make a group of 4 if you've only got 3. So the remaining counters here are 3. So it's all about counting up and seeing what's left. This is an unbelievably interesting question. This is basically spatial awareness. Olivia is making a cube from a net. She wants the cube to have 2 circles on opposite faces. Draw 1 circle to complete Olivia's net. Now, straight away, if we're thinking, think of a dice. If you're stuck on this and you can't see it straight away, think of a dice, okay? It has 6 sides. If we imagine this side, the opposite side is at the back, okay? Think of faces, rather than sides. Imagine this face at the front. The opposite face is at the back. Now, if we take this face on the top, it touches this front face. And the face on the side touches the front face. And guess what? The face at the bottom touches the front face. It shares an edge. And the face on this side touches the front face. There are 4 faces all around our dice that touch this face at the front. The only face that does not touch our front face is the opposite one at the back. So we can use this fact to solve this question. Any faces that touch this circle cannot be opposite. So it can't be this one. This touches. It can't be this one. This touches. This one is going to fold round and touch here. Can't be that one. This one is going to fold round and touch here. It can't be that one. Those 4 will encircle this face. So the opposite face must be this one here. This is a tricky spatial question. If you struggled with this one, it's well worth playing about with some 3D shapes to try and get that understanding of where opposite sides will be. But if they're opposites, they can't touch. So this is the only place where that opposite face can be. What an interesting question. Question 11. The total distance from Paris to Munich by road is 860 kilometers. There are 3 sections. This is the classic SATs question that always comes up. 3 parts to a whole and 1 part is missing. The distances for the first 2 sections are shown. How many kilometers is the last section from Stuttgart to Munich? Well, the total is 860. The first part from Paris to Metz is 331. And then from Metz to Stuttgart, it's 295. So let's add those 2 up first. Let's find out what those 2 are in total. This is going to be my first step. 1 plus 5 is 6. 3 plus 9 is 12. 3 plus 2 plus 1 is 6. That's 626 kilometers. Then to find out what's remaining, what the last chunk is, we can think of it like a bar model. 626 for the first 2 chunks, and then we have something left. Has to make in total 860 kilometers, which is here. So all we have to do now is 860, take away 626, and let's see what we get. Exchange over from the tens. 10 take away 6 is 4, 5 take away 2 is 3, 8 take away 6 is 2. We have a 234 kilometer journey. This comes up so often. 3 parts to a whole with 1 part missing. If we know the structure of this, we can solve this question very quickly. Amina says 600 millimeters is longer than 1 meter. Amina is not correct. Explain how you know. The key here is to demonstrate that you understand that 1 meter is equal to 1,000 millimeters. And you can very easily show then that 600 millimeters is less than 1,000 millimeters, which means that it's less than 1 meter. Okay, you'd put it into a sentence, but that's the key part here. You need to know this conversion fact that 1 meter is 1,000 millimeters. This proves that Amina is incorrect, and that's how you can explain how you know that she is wrong. Jack buys 4 concert tickets, and each ticket costs £28. Tick each calculation that Jack could use to work out the total cost. The first one's been done for you. Of course, we could just do 28 4 times and add them up. So essentially what we've got here is 28 multiplied by 4. But of course, that's not an option. It's been more complicated than that. Let's see which of these is equivalent to 28 times 4. Well, here we have 20 lots of 4 and 8 lots of 4. Altogether, I add them up. That gives me 28 lots of 4. this would work. The next one here, 4 lots of 20. No, at no point here, I mean, I can do 4 lots of 20, sure, but that's not giving me the 8 lots of 4 as well. I want 4 lots of 8 to add on to it, and all I'm doing here is just adding on 1 8. So that's not enough. I'd have to add on 4 lots of 8. It's not going to work. 4 times 30. Okay, so I've got 30 lots of 4. I want 28 lots of 4. So that's too much. But look what happens next. I take away 2 lots of 4. 30 lots of 4, take away 2 lots of 4, is 28 lots of 4, which is going to give me the total. So that one does work. And then finally here, 4 lots of 30. Again, look, this is what I started off with here. I took away 2 lots of 4. This is just taking away 2. That is not enough. That is not going to give me the correct total. So it's just those two there for your 2 marks for question 13. Question 14. This table shows the distances Kirsty cycled last week. Now, this is a very strange way of showing distances traveled, but it's down to us to try and figure out what's going on, interpret this data, and find the total. Now, the first thing I notice is that on Monday and on Tuesday and on Thursday, Kirsty makes the same journeys. She goes from home to school, 4.3 miles, from school to home, 4.3 miles. So actually, I can quickly work out how far she travels because I want to know how far she traveled last week in total. I can work out Monday, Tuesday, Thursday quite simply. So I'm going to do 4.3 plus 4.3. That's going to give me 8.6. So on Monday and Tuesday and Thursday, that's 3 days. So I'm going to do 8.6 multiplied by 3. 3 times 6 is 18. Put your decimal in. 3 times 8 is 24, plus the 1 is 25. And that's 25.8 miles on Monday, Tuesday, and Thursday. Cool. That's the first part done. Then I need to look at Wednesday and Friday. And you might notice again that it's the same journeys. So let's work out one of them and then times it by 2 at the end. She went home to school, which was 4.3 miles. So let's write that down. She went from school to tennis, which was 2.6 miles. Let's write that down. And then she went from tennis to home, which was 3.1 miles. Let's find the total distance on Wednesday then. 3 plus 6 plus 1 is going to give me 10. Put the decimal in. 4 plus 2 plus 3, that's going to give me 9, plus the 1 is 10. So she travelled 10 miles on Wednesday, but she did the same on Friday. So multiply that by 2, and we get 20 miles. That is the total for Wednesday and Friday. So if the question says total distance all week, I need to combine these two answers now. I need to add 25.8 and 20 together. Adding 20 is very simple. We get 45.8 miles altogether. Looks like quite a daunting question, but actually there are little shortcuts baked inside of it to try and get to the answer more quickly. Question 15. Here is a diagram made from regular hexagons. What percentage of the diagram is shaded? So the thing we need to do here first is to work it out as a fraction. Then we can do some converting to percentages after. And what we hopefully notice here is because these are regular pentagons, if we cut across this, hexagons, if we cut across this hexagon here, we're actually cutting it exactly into half. So because these are cut exactly into half like this, I think it's best for us just to draw in halves for every single one of these hexagons, because then we can have the same size parts all the way through this shape, and then we can work out the denominator really easily and the numerator. So in total here, we have how many shaded? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 half hexagons shaded. How many half hexagons do we have in total? Let's just carry on counting. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 9 out of 20 shaded because we've made that choice to make them half hexagons to make our life easier. Now we need to work this out as a percentage. And percent literally means per 100. So what we essentially have to do here is make the denominator out of 100. 20 times 5 is 100. Do the same to the top, and we get 45 out of 100 once we multiply 9 by 5, which means the percentage is 45%. A tricky question for 1 mark there, I've got to say, but it's combining lots of different maths, which we should absolutely be able to hopefully access by the end of year 6. Question 16. Here are 2 boxes, 1 1/4 kilogram, 1.4 kilograms. The mass of the first box, we can see there, I've just mentioned, is 1.25, and the second is 1.4. Often see a lot of confusion between these two, with 1.25 and 1.4, people thinking they're equivalent, and they are not. Let's see how we know that. What is the difference in mass between the two boxes? It could be tempting to put 0 if you're falling for that trap. No. 1.4 is different to 1.25. Just because they both have a 4 in them doesn't mean that they're the same. So the best thing to do here is to convert them into straight up numbers that are easily comparable. And what I mean by that is I don't want one to be in decimals and one to be in fractions. I don't want that. So let's do it. 1.25 kilograms. I'm just going to put it into grams. Okay, I'm just going to put it into grams. That might help me. Super. I'll show you a quicker way after. 1/4 of a kilogram. If you know a kilogram is 1,000 grams, a quarter is 250. So we have 1,250 grams is 1.25. 1.4, well, that's just going to be straight up 4 in the tenths, which converts to 1,400 grams. So to find the difference, I do 1,400, take away 1,250 with some basic method here. 0 take away 0, 0 take away 5. Let's do some exchanging. 10 take away 5 is 5, 3 take away 2 is 1, and those cancel out. We have 150 grams. But here's the kicker. The question says kilograms. So you'd have to convert it back if you did this method, which is 0.15 kilograms. Could you have kept it in kilograms from the start? Absolutely, you could have. And here's where having a key knowledge of equivalence is really helpful. If you know that 1/4 is the same as 0.25, which is a fact that we should just be learning off by heart, then you can very quickly change this into 1.25 kilograms. And then, because we know that the next one is 1.4, we can easily find the difference, whack it into column method, 1.25, put placeholder, and we're back where we started, but this time we're already in kilograms. 0 take away 5, we can't do that. It would give us a negative number, which we don't want here. 10 take away 5 is 5, 3 take away 2 is 1, decimal drops down, and there's 0 at the start. Gets me the same answer, but this could have been much quicker if you knew this equivalent fact. That's why it's important to learn those equivalent facts, because it makes answering these questions, hopefully, a lot quicker. Question 17. A 4 kilogram bag of rice costs £6. What is the cost of 500 grams of the rice? Well, let's work out the cost of 1 kilogram. Okay, so to get there, we have to divide it by 4, because it's 4 kilograms. So let's take £6, which we can write like this, 6.00, divide it by 4. 4s into 6 go once with 2 left over, decimal goes up. 4s into 20 go 5 times, and then there's just a 0 at the end. So 1 kilogram is £1.50. But I want 500 grams. Again, it's about knowing that 1 kilogram is 1,000 grams. So how do I get from 1,000 to 500? I divide it by 2. So I'm going to take my £1.50 for a kilogram. I'm going to divide that by 2 to get how much it would cost for 500 grams of the rice. 2s into 1 don't go, decimal in. 2s into 15, 7 times with 1 left over. 2s into 10, 5 times. It is 75p. Well done if you followed that one there. This is a 2-step problem that I turned it into. If you notice straight away that actually there are 8 lots of 500, you could have done straight away £6, and you could have just divided it by 8, and that would have got you the answer straight away. Multiple methods to the same answer. It's a common theme in these maths papers. Tick the fractions that are greater than 2/3. What we have to do here is make sure the denominators are the same. So let's take 2/3. I'm going to make it a denominator of 6, multiply the top and bottom by 2. I get 4/6. Is 5/6 bigger than 4/6? Is it greater? Yes, I'm going to tick it. 4/9. Okay, well, again, I've got it in thirds. I don't want it in thirds. I want it in ninths. So 3 times 3 is 9. Do the same to the top. 6/9. Is 4/9 greater than 6/9? No, leave it. Next one, 9/12. Okay, well, how do I change 3/3 here into 12? So I times it by 4. Do the same to the top. I get 8. 8/12. Is 9/12 greater than 8/12? Yes. Once the denominator is the same, it's really easy to see that. Next one, out of 15. Okay, cool. There are 5 3s in 15, so I'm going to multiply the top by 5 as well and get 10. Is 11/15 greater than 10/15? Yes, tick that one as well. We're going to make sure we get that answer absolutely correct. And then finally, 10 out of 21. How do I change 3s into 21? Well, I multiply by 7. Do the same to the top. I get 14 out of 21. Is 14 out of 21 Is 10 out of 21 greater than 14 out of 21? Absolutely not. So we leave that blank as well. To get our 2 marks here, we need to have ticked the top one, the third one, and the fourth one, and that will get us full marks for that question. Question 19. The total cost of a school trip for 12 pupils is £780. The total cost includes travel, food, and hotel. For 1 pupil, the travel cost is £27 and the food cost is £16. How much is the hotel cost for 1 pupil? Now, this is a very tricky question, in my opinion, because it's similar to the one earlier where we worked out the distance between 2 places because we have 3 parts and a total. But this is harder because we have to work out that total in the first place. And what I mean is we have to work out what the total for 1 pupil is. We're given the total for 12 pupils being 780. So the first step here would be to take 780 and divide that by 12. That will give us the cost in total for 1 pupil. 12s into 7 obviously don't go, so 12s into 78. Again, using your 12 times table, hopefully you know that 12 multiplied by 6 will give us 72. And that's as close as we can get there. If we have 72, there is 6 left over. Now 12s into 60 do go exactly. They go 5 times. So each child has a cost of £65 for the travel, the food, and the hotel. We know the travel is £27 for 1 pupil. We're given it here. We know the food is £16 for 1 pupil. We're given it here. We need to know what's left over to be the cost of the hotel. So our total is £65. Let's do 27 plus 16 to get the total cost of the travel and the food. 7 plus 6 is 13. 2 plus 1 plus 1 is 4. We get £43. So whatever the difference is between 43 and 65 is going to be the cost of the hotel for 1 pupil. Get 65, take away 43, and the answer down here is going to be £22. It costs £22 for 1 child to go to a hotel. £16 for 1 child for the food, £27 for their travel, and all of that works out. Eventually, if we go backwards and check all this, 12 pupils will cost £780. I think that's a very tricky question. Lots and lots of steps there to get your 2 marks compared to other 2-mark questions we've seen before. Sophie thinks of 2 prime numbers. She adds them together and her answer is 24. Write all the different pairs of prime numbers that Sophie could think of. What this is essentially testing is this. It's testing, do you know all of your prime numbers up to a certain number? Okay, up to 24. And then can you go through all of the different methods and all of the different scenarios and situations to test them to see if they can make 24 when we add 2 of them together. So let's list the prime numbers. 0 is not prime, 1 is not prime. 2 is the first prime number. Then 3 is prime. Then no other even numbers are prime because they go into 2. So 5 is a prime number. 7 is a prime number. 9 is not because it goes into 3. 11 is a prime number. 13 is a prime number. 15 is not, it goes into 5. 17 is a prime number. 19 is a prime number. 21 is not a prime number, but 23 is. So now I've listed all of the prime numbers up to 24. That's just the first part because now I need to find combinations that make 24 in total. So the first one I see, let's go to 2 and be systematic. I would need 22 to make 24, so we're not going to use 2. 3, I would need 21 to make 24, but 21 is not prime. I'm not going to use that one. 5, I would need to add 19. Aha, yes, 5 plus 19. Cross those out, we've used them now. 7, what would I need to add to 7 to get to 24? Well, I'd need to add 17. Look at that, 17 is prime. So I'm going to do 7 plus 17. Cross them out, I don't need them anymore. And now there's only 3 left. Can't be 23 because we need 1, and we know 1 is not prime. This is a classic trick. A lot of children would have put 23 on 1, thinking 1 is a prime number, but it isn't prime. To be a prime number, you need 2 factors exactly, and 1 only has 1 factor. But look at this. Luckily for us, 11 and 13, they go nicely together to make 24. Wow, lots of steps there. Well worth your 2 marks, I would say, to know all your primes and then joining them together and to not fall for the 23 plus 1 trap. Because 1, let's say it again, 1 is not a prime number. Question 21. The mass of a 1p coin is 3.56 grams. The mass of a 10p coin is 6.5 grams. What is the difference in mass between £1 in 1p coins and £1 in 10p coins? My goodness me. First thing to notice is, how do I get £1 in 1p coins? Well, £1 is 100p, so I need 100 1-pence coins. So this is basically saying 3.56 is one 1-pence coin. I need 100 of them. And when I multiply by 100, I simply shift the digits up 2 places, which would get me 356 grams. Now, how many 10p coins do I need to make a pound? I need 10 of them, because 10 times 10 is 100. So in this case, I'm going to take 6.5 grams, and I'm going to multiply that by 10, because I need 10 of those coins to make a pound. 6.5 times 10 is 65 grams, and then I need the difference. So I'm going to line up 356, take away 65. 6 take away 5 is 1. Exchange over here because we have to. 15 take away 6 is 9, and the 2 drops down. The difference is 291 grams exactly. And we're already given the G there, so we just need to make sure we write the 291 down accurately. Question 22. Find the volume of this cuboid. Now, the volume is the height multiplied by the width multiplied by the depth. So let's straight away, 1.5 is jumping out at me as a tricky part of this. So I'm actually going to get rid of it straight away by multiplying 2 times 1.5. Let's multiply the height by this depth. 2 times 1.5. We can split this up. 2 times 1 is just 2. 2 times a half, 2 halves make 1 whole. So that's just 1. So if I put them together, it gets me 3. So 2 times 1.5 is 3. And now all I've got left to do, because I've multiplied these together, is to multiply the width. I've got 3 as my answer to the first multiplication. So I do 3 times 12, and I get the answer 36 centimeters cubed. That fraction there is the thing built in to try and trick you. Otherwise, quite a straightforward question. Question 23. The distance from A to B, which is A to B, is 3/4 of the distance from A to C. So what we basically see here is A to B is 3/4, so we chuck it into 3 parts, of the total, which is A to C. So you can see now I've cut the whole thing into 1, 2, 3, 4 parts because we're in quarters. So A to B is 3/4 of the total distance. That works out because it's 1, 2, 3 out of 4 in total, 4 jumps from A to C. So what's the distance from B to C? We can work this out now. Because I know that these 3 jumps are 24 kilometers, I can do 24 divided by 3. That's going to give me 8. So I know that each of my little jumps here is worth 8. Therefore, if I'm working out B to C, that's just one of those jumps I've just calculated. And the answer is 8 kilometers. That's why when I do a lot of teaching on YouTube, etc., you see lots of my videos, I do bar models, because this is basically a bar model. It's just written on a number line instead with 4 equal parts. It does help in these trickier questions. That's the end of that paper, guys. Hope you found it useful. Leave it a like if you did. Comment down below. Subscribe for more because we've got all the test papers coming. And I'll see you again next time for another one of these walkthroughs. Bye, guys.